Hello there, Mr. Sutton here, bringing you the Algebra 2 4-8 Part 2 homework solutions on analyzing graphs of polynomials, specifically focusing on even and odd functions. To see whether this function is even or odd using the even-odd test, we're going to go ahead and we'll do the even test first, plugging in negative x for x and seeing if that gives us what we started with. So we're going to do g of negative x, that's negative x going in for all the x's. That becomes, this is going to become x to the fourth plus x squared, and we still have that minus 1 there. Now comparing g of x and g of negative x, it looks like these two things are exactly the same. That tells us that this is an even function. And just doing a little analysis on the exponents, 4, 2, and there's an invisible x to the 0 here, those are all even numbers, so that's what we would expect. For this problem, to see if this is even or odd, we can do a quick check with the exponents first. Since we have a mix of even and odd exponents, 2 and 1 and 0 there, this indicates that we're going to be failing both the even and odd tests, but we're going to show them anyway just to really rigorously prove this. So for the even test, let's plug in negative x for x and see if g of x and g of negative x are the same thing. So g of negative x, that's giving us positive x squared, which matches what we started with, and now negative 5x is different, and that plus 1 is still there. So g of x does not equal negative g of x. This proves that this is not an even function. To prove whether or not it's an odd function, we have to do negative g of x, which basically means we negate everything in the g of x function, and then we'll compare that to g of negative x. So we've got negative x squared minus 5x minus 1. This does not match g of negative x that we calculated earlier. This proves that this is also not an odd function, so then this is neither. On this problem, to figure out if this is an even or odd function, let's first do the quick sort of cheat and look at the exponents. 6 and 2 are all even, so that indicates that this is going to be an even one, but let's prove it with the even test. So we'll plug in negative x for g and see if that matches what we get when we do that matches what we started with. So g of negative x, this is going to be negative 2 positive x to the sixths, and then this is going to be a plus x squared, and that does match g of x right here. So because those two things match, this proves that we do have an even function. For this problem, checking even and oddness, it looks like we have 3 and 1 for our exponents, so we expect that this is going to test positive for oddness, but let's just do all our tests to be sure. So first off, we're going to calculate f of negative x, and while we're doing that, we can check to see if it's even or not. So f of negative x, that's negative x cubed minus 7 times negative x. That becomes a negative x cubed in front, and then this becomes a positive 7x. Since f of negative x here and f of x don't match, this proves, which we kind of already knew, that this is not an even function. Now let's do negative f of x and see if that matches up with what we already got for f of negative x. So negative f of x, we're essentially negating everything. That gives us negative x cubed plus 7x. And that does indeed match f of negative x. Since those two things are the same, that proves beyond a shadow of a doubt that this is an odd function. For this one, to see if we are even or odd, let's first look at the exponents and kind of estimate this. We have a 5, a 3, and a 1. These are all odd exponents, so we expect that this is going to come out odd when all is said and done, but let's rigorously prove it now. First, let's find f of negative x. So that's going to be negative x plugged in for all the x's here. That comes out to negative x to the fifth. This is going to be negative 3x cubed, and this is a plus x. Now, just while we're in the neighborhood here, let's test for evenness. Since this does not match the original f of x function, since those two things are not the same, this proves while we're there that this is not even. Let's now prove it is going to be odd by doing negative f of x. That negates everything that was in the original function. So negative x to the fifth minus 3x cubed plus x, if we distribute that negative there. And that does match f of negative x, since f of negative x and, hold on a sec. There we go. All right, that's the correct letter. Since f of negative x and negative f of x do match, this proves that we have an odd function. For this problem, to see if this is even or odd, we can first sort of estimate it by looking at the exponents. So we have a third power here, and this is really an invisible x to the 0, so that counts as an even. Since there's a mix of odd and even exponents, that suggests that this is going to fail both the even and odd tests, but let's actually run those now so we can prove things. So let's plug negative x into the h function to start off here. That just negates this 1x here. This gives us negative x cubed plus 2. That doesn't match h of x. Since those two things, h of negative x and h of x, are not the same, this proves that we are not even for this one. And now to see whether or not it's odd, we do negative h of x and compare that to h of negative x. So negative h of x, that negates everything. That's negative x cubed minus 2. And that also does not match h of negative x. So since those two don't match, this is also not odd, which means it is neither even nor odd.